Me imagino que ustedes conocen.
I suppose you know what the coded or computer-based language means is a system to facilitate lip reading by deaf people, thus getting rid of any ambiguity that could be deriving from lips movement. Many letters are similar from phonetic standpoint. So to avoid this confusion, we have a coding system which you use your hands to indicate a type of vowel or consonant when the consonants are ambiguous. So what we're going to see today is based upon that type of coding that has little to do with the sign language, which is a language per se, and the automated interpreting would be impossible, as you've seen this morning. The grammar and structure and the language elements are completely different from oral language. So this is why this other system allows this kind of automated approach.
I'm Ella Dassi, researcher and teacher in the University of Paris 8. I am a member of the lab Technology, Handicap, Interface, Mutualité, Multimodalité, managed by Professor Jaime Lopez Crae. The work presented here is an extension of the old LabYAO project. LabYAO means in French lecture labiale assistée par ordinateur, which means in English computer assisted lip reading. The aim of the French project was to provide lip readers and especially deaf and hard of hearing people with an artificial talking head piloted by automatic speech recognition. The talking head can be lip read and optionally can produce code speech. The code speech is a codification system that complements lip readings. In fact, as many French phonemes look identical on the lips, the hand shapes in different positions near the mouth can suppress this ambiguity. I invite you to see this video of a talking head that produces code speech. The sentence is in French. Je suis un agent conversationnel, which means in English I am a conversational agent.
Je suis un agent conversationnel. Je suis un agent conversationnel.
So we have remarked that the system users require not only the linguist context speech, but also its emotional part. So the talking head can be clearly improved by the introduction of advanced techniques for recognition of speakers' emotional state. For this reason, the aim of our research is to extract from speech prosodic information from naturally speech signal to identify the emotional state of the speaker in order to animate the talking head. Our current application domains are: with our proposed system, school and education centers must be accessible. In fact, the speech of the trainer can be animated with the talking head, which will give double information, linguistic content, and emotional part, and the emotional part of the speech. So the talking head will give this information through PDA screen or computer screen, which will be placed in front of the student, of the deaf student. With our proposed system, also, meeting and conference must be accessible. The speech of the participant, like me, can animate the talking head, which will have the profile physical of the participant. So, deaf and hard of hearing people can be able to easily understand the speech. Besides, with our proposed system, we can offer freedom for the deaf and hard of hearing people to use the telephone and to have access to information via telecommunications. Finally, with the implementation of the proposed system, we can improve the use of video phones, and you can improve the use of the mobile video phone for deaf and hard of hearing people. I will explain the overview, the principle of our combined system. Our idea is, from the speech signal, we can extract two informations in order to animate the talking head. In fact, the first information is the linguistic content speech, which will use to animate the lip movement. The second information is the emotional state of the speaker, which will animate the facial expression of the talking head. And we can visualize both animation, lip movements, and facial expressed on a terminal. The software tools for the realizing of our system, we use the Dragon Naturally Speaking for the speech recognition, to have the text, to have the linguistic context, and we use WinSnori to extract the prosodic information, and we use Greta for the talking head. I will explain the prosodic elements estimated by the software WinSnori. I take the example of this sentence, which is articulated by a female speaker. The content of the sentence is La partie de belote dura toute la journée in French, which is here in Spanish. I invite you to...
La partie de belote dura toute la journée.
And here we present...
La partie de belote dura toute la journée.
In curve red, the speech signal acoustic. In curve black, the spectrogram of the signal, which is the Fourier transformation of the signal.
La partie de belote dura toute la journée.
And we present the variation of the pitch, which is the fundamental frequency, which is the important information, the important prosodic information. And we have the double annotation, orthographic annotation, and phonetic annotation.
La partie de belote dura toute la journée.
Donc the curve on mauve is the variation of the pitch, which is the important prosodic information. We can, WinSnori can estimate also another parameter of another prosodic parameter, which is the energy, variation of the energy. For the same sentence, we present the variation of the energy curve in blue. WinSnori can also, the software can also calculate the duration of the phone and the word in the sentence. For example, for the sentence La partie de belote dura toute la journée, the duration of the word la is given here. As we note that there is a difference in this duration for the same sentence, which we pronounced by the same speaker. We can look here, la, here, the acoustic presentation, and la is here, the acoustic presentation. There are a difference. to more understand the parameter, the prosodic parameter, we will take an example of the same sentence articulated by the same female speaker in two different situations, happiness situation and anger situation. And for each situation, I have presented the variation of the important prosodic information, which is the pitch, the fundamental frequency curve in morph. I invite you to listen for the happiness case.
La partie de belote dura toute la journée.
And we present here the variation of the pitch. I invite you to listen to the anger situation, the same sentence by the same speaker.
La partie de belote dura toute la journée.
We remark that the variation of the pitch isn't this.